Hello everyone, I am Jagdish Patel, Assistant Professor, Sandeep Foundation, Nasik. The name of subject is Broadband Communication System. This is Unit 1, Light Wave System Components, and this one is lecture number 3, in which we are going to see light wave system components. I am having 12 years of teaching experience, specialization in digital communication. Benefits of optical links. 1 of 2. Imurious capacity 1.3 mm to 1.55 mm, allocated bandwidth of 37 terahertz. Cables and equipment have small size and weight. A large number of fibers fit easily in an optical cable. Applications in special environment as in aircraft, satellite and ships. Long distance, less attenuation per distance. Optical fiber losses can be as low as 0.2 dB per kilometer compared to the loss of coaxial cable 10 to 300 dB per kilometer. Almost zero frequency dependent loss. Dispersion limitations, chromatic 5 ps oblique nanometer oblique kilometer. Low power, less attenuation. So these are the benefits of optical links. Less noise, no crosstalk between fibers, no reflections. Immunity to interface, nuclear power plants, hospitals, EMP, resistive systems, installation for defense. Electrical isolation, electrical hazardous environment, negligible crosstalk. Signal security, that is banking, computer network, military systems, etc. Silicon fiber abundant raw material. So these were the benefits of the optical fiber. Now progressive light wave communication technology. First generation fiber optic system, second generation fiber optic system and so on. So starting with the first generation fiber optic system. Purpose: eliminate repeaters in T1 system, use in inter-office trunk links. Technology 0.8 micrometer semiconductor laser, multimode silicon fiber. Limitations: fiber attenuation, intramodal dispersion, deployed since 1974. Second generation fiber optic system, opportunity: development of low attenuation fiber, removal of H2O and other impurities. Eliminate repeaters in long distance line. Technology 1.3 micrometer multimode semiconductor laser, single mode low attenuation, silicon fiber, DS3 signal, 38 multiplex DS1 signal carried at 44,736 megabyte per second. Limitation: fiber attenuation, repeated spacing 6 km, deployed since 1978. Third generation fiber optics system, opportunity: development of Abraham-Dopf fiber amplifier, technology 1.55 microampere, single mode semiconductor laser, single mode low attenuation silicon fiber, OC48 signal, 810 multiplexer, 64 kb per second voice channel carried at 2.4488 gigabit per second. Progress in light wave communication technology. Limitations: fiber attenuation, repeater spacing 40 km, fiber dispersion, deployed since 1982. So if you observe here in the graph, 0.8 micrometer, that is multimode, 1.3 micrometer, that is single mode, 1.55 micrometer, that is single mode laser, coherent detector, optical solutions and optical amplifier. And the years when they are being deployed are given below. And their performance in terms of GB per second per kilometer is given. So the graph shows the variation deployed year and their performance according to their use. Fourth generation fiber optic system, opportunity: deregulation for long distance market, technology 1.55 micrometer single mode narrow bandwidth semiconductor laser, single mode low attenuation dispersion shifted silica fiber, wavelength division multiplexing of 2.488 gigabit per second or 9.953 gigabyte per second signal. Limitations: non-linear effect limited to following system parameters: single launch power, propagation distance without regeneration, relocking, WDM, channel separation, maximum number of WDM channel per fiber, polarization, more dispersion limits the following parameters: propagation distance without regeneration or relocking. Deployed began in 1994. Wavelength multiplexing. If you observe here, this is WDM, ETDM, OTDM used for commercialization or experimental. So here it shows according to the performance parameter of wavelength multiplexing. Optical network architecture. Here this is showing the optical network architecture where there are different layers, starting with the optical layer, dense wave division multiplexing, optical fiber, add drop multiplexer, WDM, DWDM, ADM. Next is transmission layer, part of the physical layer, SONET, ADM, DCS, that is digital cross connect, SONET, SDH, ADM, add drop multiplexer. Next is service layer, layer 2, 3, etc. devices, voice, PSTN and wireless, voice switching, ATM, fiber relay, IP, internet, multimode and video. WDM provides enabling technology for optical network layer, data format, transparency for multi-service optical layer, optical channel bandwidth management and high capacity throughput. Optical network architecture. Here it consists of ATM, SONET, SDH, access, metro, long haul, and they are connected to different sectors. So these are the fibers which are connected with the help of couplers and to a different parameters to transmit the signal from the receiver to the destination user, which can be used for local access, metro access, long haul access, etc. Traffic growth and composition. This one is a traffic growing day by day. So IP is internet protocol used for internet and ethernets. FR is the frame relay. ATM is asynchronous transfer mode. PL is a private line dedicated point-to-point bandwidth. So here we can observe the different parameters and their uses as shown in the graph. DWDM technology. Here WDM multiplexer is used to which the different number of frequency register transmitter are connected. It receives the signal, transmit the signal over optical fiber cable, then the signal is given to the amplifier used to amplify it, gives to the amplifier connected in the receiver side. After the amplifier output is given to WDM demultiplexer, and the multiplexer output is given to the number of users or receivers connected on the receiver side. So this one is nothing but the actual component, and they are connected in DWDM technology. So here this one is a graph showing the details how the signal has been transmitted from the receiver to the transmitter to the receiver. Evolution of WDM system capacity. Repeater spacing for commercial system, long haul system 600 km repeater spacing, ultra long haul system 2000 km repeater spacing, Raman plus EDFA amplifier, forward error correction coding, fast external modulator, metro system 100 km repeater spacing. State of art in DWDM. Channel spacing is 50 GHz, 200 carriers, 1000 gigabit per second repeater spacing, few thousand kilometer. And here this one is global, undersea fiber system. Here if you can observe, whole world is using and deployed the optical fiber submarine system. Here the fibers can be deployed underwater also to transmit the signal, to transmit the information over one corner of the world to the another corner. Because of the no noise separation and high quality of bandwidth or high signal quality. Installation fiber in US. See, the complete US, United States, is covered with the optical fiber. That's why the speed of the network, internet, voice clarity is very good in the United States. So this is the effect of using a fiber for the communication system. About 50 routes miles of 1500 or 5000 route miles of fiber are deployed in United States. So these were the components we have seen for optical fiber, their uses, their generation by generation, the changing of fiber, changing of the quality of the fiber, different parameters and the year of deployed or the year of origin. Thank you.